and Assalamualaikum everyone. In this video, I'm gonna be presenting my research proposal, which is bitter leaf sweet results and investigation about Vernonia amygdalina as an anti-diabetic properties. Before that, let me introduce myself. I am Maria Cristina Binti Azizan, a year 2 bachelor degree in Science Chemical with matrix number S63715. So let's get started. This is my project review. The objective of this research is to investigate Vernonia amygdalina's potential as a natural remedy or therapeutic intervention for treating diabetes. My goals in this research are gathering scientific evidence to support the Vernonia amygdalina's benefits to diabetes management and understand mechanism and assess the effectiveness for glucose in the blood. First, let me share some information about diabetes to you. Diabetes, or its scientific name, diabetes mellitus, is a chronic diabetic disorder due to increase of glucose level in our bloodstream. Diabetes is caused by the inability of the beta cells in pancreas to produce enough insulin, or our cells cannot use the insulin that produced effectively. What is insulin? Insulin is a hormone that was produced by the beta cells in pancreas that assist the cell to absorb and stabilize the glucose in our blood. Now, how does insulin work? As you can see here, our cells has insulin receptor and glucose channel. Insulin acts as a key to the insulin receptor to open the glucose channel so that the glucose can be absorbed and it will convert it to energy. There are two types of diabetes. First one is type 1 diabetes. Type 1 diabetes, also known as insulin-dependent diabetes, is where our body cannot produce enough insulin. It is an autoimmune system where the immune system mistakenly attacks the beta cells in the pancreas that leads to a lack in insulin to our body. The exact cause of type 1 is unknown, but it is believed to involve with genetic and environmental triggers. Usually accounts for approximately 5% to 10% only for all of diabetes cases. Second one is type 2 diabetes. It is known as non-insulin dependent diabetes. It occurs when the body becomes resistant to effects of the insulin or does not produce insulin. Type 2 diabetes is strongly associated with obesity, physical inactivity, unhealthy diet, and genetic. Both of these types of diabetes will cause inflammation, heart attack, stroke, or even affect our inner organs and nerve system. Now, our main character, Vernonia amygdalina. It is very famous of the name bitter leaf. It is a plant member from Astraceae or daisy family. The native of the bitter leaf is West Africa, but can also found in many regions of the world, which include Asia. It has bitter taste that indicates the presence of bioactive compounds that exhibit the potential of anti-diabetic properties. These are some examples of bioactive compounds that can be found in Vernonia amygdalina. The first one is flavonoids. Flavonoids act as antioxidant and anti-inflammatory properties. Alkaloids act as potential for antioxidant properties, where terpenoids, it acts as antimicrobial, anti-inflammatory, and antioxidant properties. There are three methods that I include in my research. First one is phytochemical screening. The method that will be used are Dragendorf to detect alkaloids, Salkowski to detect steroids and terpenoids, Ninhydrin to detect amino acids, and Lieberman-Burchard to detect sterols in the plant. Whereas the FTIR or Fourier transform infrared spectroscopy, the powder of extract Vernonia amygdalina will be run in potassium bromide, which is KBr pellet, to identify the functional groups contained in Vernonia amygdalina. The third one is observation on rats. There are two groups of rats that will be divided, which is non-diabetic and diabetic that will be prepared. The rats will be given the dose of leaf, stem, and root of Vernonia amygdalina extracts, and then the observation will be recorded based on the blood glucose percentage. This is the expected result for phytochemical screening. For FTIR spectroscopy, the expected result will be referring to this spectrum. We can see that there are some noticeable functional groups such as OH group, alkyl group, carbonyls, and alkenes. Observation of rats, we can see that the non-diabetic rats will be no difference of blood glucose levels within 4 hours. But in diabetic rats, there are very huge difference within 4 hours in the leaf and also root dose. To conclude my research, I can say that Vernonia amygdalina has the potential to treat diabetes because it contains many bioactive compounds and can at least reduce the various effects on the body due to the disruption in normal blood glucose regulation. Of course, more studies needed to support the expected results, and a better research can be made by running more spectroscopy on Vernonia amygdalina. This bitter leaf can give sweeter results. I hope this research is beneficial for you. That's all from me. Thank you.